Welcome to Calculus. Fractions will pop up when you least expect it. On this episode, Stevenson will demonstrate
Now let's use our fundamental theorem and let's apply it to a context. So here we go. A rainstorm begins at 2 p.m. An empty bucket that has been left outside starts to fill at a rate that is approximated by R of t equals, and then we have this polynomial expression. R of t is measured in centimeters per hour, where t is on the closed interval between 2 to 6, and t is measured in hours after noon. How far does the water level in the bucket rise between 2 p.m. and 6 p.m.? All right. So what we want to know is how much rainwater accumulated over that time period. So let's start by writing an accumulator function. So my accumulation is going to be the integral of this rate function starting at 2 and ending at some unknown time. Now the reason why I want to accumulate is because I want to add up the areas under the rate function, right? Because if I can figure out the area under a rate, that represents my total output. So in this particular case, what am I actually looking for? I'm looking for how much does the water level in the bucket rise from 2 to 6. So I want to know how much changed only on that time interval. It's not asking how much was in there in the beginning or how much total's in there. It's just how much change happened. So essentially what it's finding, or what it's asking for now, is what is f of 6. So that would be from 2 to 6 of my rate function right here. Because my rate function here is telling me how much the how much the bucket is filling. That's the rate that's telling me that. So for the purpose of this problem here, we're going to go ahead and put this in our calculator. So we got f of 6 is 6.7555 and 5 is repeating. Okay, so in this particular case, you could say f of 6 is 6.755, or you could say f of 6 is approximately 6.7, or you could say 6.756. You can round here. So you either truncate your answer, or you can just round it at the third decimal place. But what are the units here? Well, let's pick apart our integral. The integral is going to give away and help us what's actually going on. So we're doing r of t times dt. So look at r of t. What are the units of r of t? It's centimeters per hour. Times. dt is change in time, but how is time measured? Time is measured in hours. Notice the hours will simplify and you're left with centimeters. So I know these units are centimeters. So this means the amount of the water level in the bucket rose approximately 6.755 or 756 centimeters during the time period from 2 p.m. to 6 p.m.